Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. As usual, I first request you please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as your explanation. I believe you have tried, so let's start. Now what is the major product of these reactions? So if you look at it, is actually a three ring fused together, both side benzene with a double bond. So it reacts with methyl magnesium iodide in anhydrous ether. So this is Grignard's reagent, and second step H plus and heat. What is the product? Student, when you get such kind of question, you need to understand about the reactivity of both reactant and reagent. So if you look at these molecules, this carbon is delta positive, this is delta negative. So you can say this carbon center is electrophilic. Electron deficient, it's electrophilic. So any group having more electron density can attack here. Now if you look at CH3MgI, methyl magnesium iodide, there is a carbon magnesium bond. So because of the electronegativity difference, this magnesium is delta positive, carbon is delta negative. So slight excess electron is there. So this is student nucleophilic in nature. By the way, you may ask one question that, sir, there is a significant electronegativity difference between magnesium and iodine also. So this is delta minus. So why this methyl group is acting as nucleophile? Why not iodide? Actually, it depends on the stability. Look at iodine is halogen group. So it's a higher electronegative atom compared to carbon. So negative charge on this carbon is slightly more reactive or less stable compared to negative charge on iodine. So that's why this part will participate as nucleophile. And where it will attack? It will attack here. So what will happen? So in the first step, this methyl will attack here and it will be open up. So what it will produce? This is methyl, the attached O minus, and in order to balance the charge, there is actually Mgi plus, means whole moiety plus as a counter cation. Now next step, work up. So actually I have given H plus and heat. It means H plus there in the medium. So this H plus will neutralize this O minus first. Alkoxide, stronger base. So what it will produce? It will produce a tertiary alcohol derivative. Okay, actually I would say it is benzylic as well as tertiary. So those two factors are here. Now next step, again tertiary alcohol, it can undergo protonation easily. By the way, remember tertiary alcohols are prone to protonation. Why? Because after that it can release very efficiently. Why? Because when it releases, it produces a carbocation. Actually here I would say it is actually student tertiary as well as benzylic. Look at CH3. So this position positive charge is there. It is benzylic with respect to both of the benzene ring. Stable. Not only that, it is tertiary. So this is the carbocation. Now what will be H plus and heat? Means a lot. Heating is also given. You can see here H plus and heat together. So we know generally heat prefers elimination. But actually elimination will take place from here. Generally we have observed that next to the positive charge, if there is at least one hydrogen, this hydrogen is eliminated as a H plus, it comes and produce alkene. So this is the general understanding, like alcohol dehydration to alkene, acid catalyzed, like that. But here why this proton? In order to understand this, you need to understand the vinylology. I'll explain. Now here what will be the product? You can expect this is one benzene ring, another benzene ring. By the way, student, I am drawing on a plastic board. That's why my drawing may be poor, but I request everyone, please draw it properly. Practice. So it will be abstract, means someone will abstract molecule, this H plus will go, so it will come here, it will go there. So in this way, so actually you can understand three ring having aromaticity. Okay, this is the product. Now question, whatever, why not this? Actually if you look at, this is happened like that, double bond, positive charge, and here hydrogen. So this hydrogen was eliminated. Now this is actually called vinylogous property shifting. I mean this phenomena you can explain by the concept named as principle of vinylology or vinylology. I have already uploaded a dedicated lecture on it. You may visit for further learning. So since one double bond present, the property could be shifted. Another example, you can expect it, okay, this is your pH, this is CH3. So enolization possible as it has 3 alpha hydrogen, agree. But you can look at here also. So this is double bond O, this. Now this is CH3. So this position, although it is not at all an alpha position, but these positions reactivity will be similar like the alpha position. Now you can say, sir, here also alpha proton, but that is sp2 hybridized. sp3 hybridization needed. So that hybridization is available here. So if you give base, proton will be abstracted from this position, not this. So this it will participate in aldol condensation because the produced carbon ion will be resonance stabilized by this double bond. So this is a vinyl group which is shifting property. If you give two vinyl group, property will be shifted further. So this is principle of vinylology, very interesting concept, please read. So here you can expect, okay, because of this principle of vinylology, this proton is abstracted and it resulted in alkene formation. Okay, so you can understand this is one methyl, this is one methyl anthracene. So okay, what is the option? You can see option C is the right answer. Now just you may ask one question, that sir, there is one option possible that this Grignard reagent can act as base. Yes, it can abstract this proton. Yes, so carbon ion will be generated, I mean here, that can undergo resonance and it will produce a OH group. So these keto means it's a tautomerism type of thing. So this proton could be shifted from there to there and ultimately I will get this kind of product. Okay, so actually it depends on student situation to situation. In this context, this is the product. Okay, and just imagine when you are solving this question, did I give any option having OH? So answer is no. What does it mean? I want to say that, okay, this pathway is not happening. I have seen that many students ask, sir, what could be this? Remember, in a chemical reaction, many options possible. But means actually a chemical reaction can be happen by infinite number of pathways or infinite number of possibility could be there. But only that or those pathway will be followed which is associated with lower energy of activation. Okay, now so what happens here? So methyl magnesium iodide anhydrous ether reaction, this one. Now if you get this question in your exam hall, how can you solve it? So first you look at the options, no OH given, so this option gone. Now second, I suggest student carbon count. It is a very important strategy. So here methyl magnesium bromide, so it is a C1 and it's a this ring extended with another carbon. So ring is there extended with two carbons should be there. So here, okay, matches, here matches, here matches, but here look at only one carbon. So it is gone. It's a very unique strategy and this is called process of elimination. So now your discussion is in between these three options. Now methyl magnesium bromide, it's a nucleophilic reagent. Okay, so it will attack a electrophilic center. Is this carbon a electrophilic center? Remember, the carbonyl group's alpha position is not a electrophilic center, it is a nucleophilic center. Now if you put a vinyl group, then this carbon will be, this carbon is, you may consider this carbon will be nucleophilic. Okay, this is the chemistry. This is not, cannot be electrophilic. So how this methyl group can attach here? It's a very wrong concept. So it is also gone. Second, okay, fine. So here you can expect that, sir, whatever I told after nucleophilic addition, this is the product. So from there they are saying that, okay, double bond. So this carbocation, I am saying H hydrogen will be abstracted, eliminated from here, but they are saying why not the another one? Means in the neighboring position, as I told, in the next carbon there are 3 hydrogens. Why it is not abstracted? So remember, what is the product? It is actually exocyclic double bond. This is exocyclic double bond. Generally exocyclic double bonds are not that much stable. Not only that, in this case there is actually a sp3 hybridized. So these ring number 1 2 3 3 are not aromatic, but if you look at here, 1 2 3 all are aromatic. Aromatic means stable, so molecule will follow this pathway such that more stability or aromaticity could be obtained. In this way you need to decide whether it will be A or C. So C is because it's aromatic. Now this process you need to do faster in your mind. It's not a tough, but this problem mainly it's a time consuming. So time thing you can deal by more practice. Okay, so this is the overall discussion. I believe this video will be useful, and if you really consider the content of my channel is worthy, then please help this channel to grow. And regarding any doubt about the logo of my channel, please read this part. Thank you and see you in my next video. Bye bye.